Okay, number 5. Graph the following. Sorry, I have to bring it up. Polar functions. I'm gonna say nope. I'm not doing that. Too long. You can check them on Desmos. We can talk about them in person. I'm definitely not doing those. I already took this class. I don't need to pass it. Haha. All right. Convert. What the heck do you want, Will? All right. Convert to rectangular. Oh, I'm sorry, to polar. Maybe I didn't pass this class. Convert to polar, and these are complex numbers. So the standard form of a complex is a plus bi. We know that if we convert that to polar, the a would be r cosine theta, and the b would be r sine theta times I. Typically, we want to factor out the r, so we'll call it cosine theta plus I sine theta. We put the I in front so it doesn't look so confusing. So that's the form we're going to want to write these guys in. So for A, we've got 3 minus 3i. So if I look on the complex plane, remember this is a number system. It is not like I'm graphing on the x and y plane. Okay, I am over 3 in the real direction and down 3 in the imaginary direction. So I know that that's 3 and that's 3. So again, the r is going to be the square root of 3 squared plus negative 3 squared. Oh, sorry, that's a negative 3. So again, I recognize that as a 45, 45, 90. So I know it's going to just come out to be 3 root 2, right? But if I go through this, I've got the square root of 9 plus 9. That's 18. I told you I passed this class. And then 9 times 2, that's 3 root 2 like we suspected. So this is going to be 3 root 2 times. Now we just got to find out that angle. Well, like we said, that's negative pi over 4. So we go 1 pi over 4, 2 pi, 3, 4, 5, 6, 7 pi over 4. So it's going to be cosine of 7 pi over 4 plus I sine 7 pi over 4. That's A. B is negative 1 plus I root 3. So that's going to be negative 1 and then up positive root 3. So we're up here in quadrant 2. And it's 1 unit that way. I know it's negative, but whatever. And then it's root 3 units that way. I recognize that as a 30, 60, 90 right triangle, right? Because the root 3 thing. So that's the short. 1 is the short leg. So root 3 is the long leg. So that means this angle here is 60. So that means that's 120, which is what, really 2 pi over 3. So that angle is 2 pi over 3, and that radius is 2. So it's going to be 2 times cosine of 2 pi over 3 plus I sine of 2 pi over 3. C is 4i. That's right there. That distance is 4. That rotation is pi over 2. No bells. See you later. So then the radius is 4 cosine pi over 2 plus I sine pi over 2. D is 6 minus 2 root 3. Later, I'm going to write that like this. 2I root 3. So that's going to be 6 on the real direction and negative 2 root 3. So we've got 6 and down, so that's 6. That's down 2 root 3. Again, I smell a 30, 60, 90 here. So it looks like 2 root 3 times root 3 is 6, which is indeed the case. So that means that 2 root 3 is the short leg. So that means this angle in here is 30 degrees. And then if I double it to get the hypotenuse, I get 4 root 3. So the radius is 4 root 3 times cosine of, now instead of negative pi over 6, because that's 30, right? We're going to do 2 pi would be 12 pi over 6, right? So we're 1 short of that. So it looks like 11 pi over 6 plus I times sine of 11 pi. Close it. All right.